Welcome, Vanessa.
Thanks, Regina. And welcome everyone to our Signals Coffee and Conversation on LiDAR detection in practice, where we'll hear lessons from Connecticut agencies. We're so happy that you're able to join us this morning and for the opportunity to advance these educational opportunities here at the T2 Center. Like Regina mentioned, I'm Vanessa, an educational program administrator with the T2 Center, and I coordinate our traffic signal efforts, and I will be the moderator for today's session. This morning, we'll have presentations from Stephen Frycz, who serves as the transportation manager for the City of Stamford's, Transportation and Parking Bureau. And since joining the city's traffic signal team in 2006, Stephen has played a pivotal role in the operation, maintenance, and advancement of the city's network of 211 municipally owned traffic signals. Also joining us, we have Fred Eshraghi, who is the City of Norwalk's traffic engineer. He has 26 years of experience in transportation engineering and intelligent transportation systems, or ITS. Fred specializes in integrating innovative technologies to improve roadway safety, optimize traffic operations, reduce congestion, and enhance mobility. From the Connecticut Department of Transportation, we have both Andrew Lenoce, who is a design engineer for the CTDOT Signal Lab. Andrew has been employed with the Signal Lab for 3.5 years with a focus on emerging technologies and networking. And as part of CTDOT, Andrew helps maintain the 2,600 plus intersections in the state with regards to detection, connectivity, and so on. And then also with the DOT, we have Robert Farrelly, who is a design engineer, also with the Signal Lab, and his responsibilities include plan design review, project inspections, and maintaining intersections owned by the state. So since December of 2025, Robert and Andrew have been working together and testing LiDAR for ITS applications for CTDOT. So just to kind of outline the structure for today's session, we'll have Stephen, Fred, Andrew, and Robert give brief presentations on the LiDAR detection technology, highlighting their experiences, lessons learned, and applications of the technology. And in case you're unfamiliar, LiDAR, or light detection and ranging, is a remote sensing technology that uses rapid laser pulses to map environments and measure distances. By calculating the time it takes for a laser beam to bounce off an object and return, the system creates highly precise 3D representations of the surroundings. And in transportation, this is used to detect the vehicle and all vulnerable road users. Just a couple of other things. So just please note that in the session today, we might have representatives from private agencies participating, but the session is not intended to promote any specific company or product. And so after the presentations, we'll open up the conversation with a Q&A. But during the presentations, we do encourage you to post your questions and comments in the chat. I'll be monitoring the chat throughout the session, and our presenters will be answering your questions as well. Again, please do not unmute during the presentations. If we do have time at the end of the session, we'll open up the floor for you all to unmute. And with that, I will go ahead and stop sharing here. I will turn it over to Fred. Fred, I will pull up your...
All right. Good morning, everyone. Are we good?
Morning, Fred.
Awesome. Good morning, everyone. Thank you for joining us, for today's coffee and conversation on LiDAR detection technology. Fred Eshraghi, State Traffic Engineer with the City of Norwalk. We would like to talk about a little bit, new technology and detection system. Over the past several years, we have been evaluating and deploying a variety of traffic detection technology, including video radar, microwave, and more recently, radar. Our goal today is to talk about the LiDAR detection technology, and what we would like to discuss is where the LiDAR provides the greatest value, and what we have learned through implementation and installation, and also how agencies can make decisions as they modernize their transportation infrastructure. I would encourage everyone to share their experiences during this conversation, whether you already have deployed the LiDAR, are evaluating it, or simply wants to learn a little bit more about it. So please feel free to share all of your experiences with us. To get started, we have 3 questions related to this conversation. The first question is, what motivated your agency to consider LiDAR instead of traditional video detection? If we want to think about it deeply, so there are 2 big reasons, for us to look into the different technology in detection. Number 1 is improving reliability and safety. If I want to just give you guys a little bit, deeper information, traditional video detection has served the industry for the last 25, maybe 30 years. I myself installed the first one in the city of Norwalk in 2006. And since then, I have 250 video detection installed in our intersections, including directional, which we have camera for each direction, and also the fish cameras. Both of them, has been good to us. They have significantly improved traffic detection and safety, but all of them struggle in environmental conditions such as darkness, low sun angles, glare, shadows, rain, and snow. These limitations are one of the key reasons agencies are, start researching and evaluating different technology, and recently is the LiDAR detection, which provide more consistent and reliable detection regardless of lighting conditions. They create precise 3-dimensional model of the intersection, allowing us to detect vehicles, pedestrian, bicycles, and all other road users with a much higher level of confidence. Another significant advantage of the LiDAR detection technology is its ability to accurately classify objects while maintaining privacy. Just listen to this, privacy, as no identifiable image are recorded. When we go to the software and we will show you the demo unit that we have installed, you will see a little bit of video at the intersection as well, but that's not the video. This is all from the LiDAR detection. So privacy will be there, and to classify the object at the intersection, they do not need to record any video. So privacy, it's the most important, one of the most important part that, just push us to do a little bit deeper research and implementation for the LiDAR detection. Another basically point for start using the LiDAR detection is it's the new application available in the market. The most important part of it is the safety measure, like near misses analysis, conflict monitoring, also in the traffic, in basically industry, like adaptive system, pedestrian safety, and data-driven, traffic operation. I will show you a little bit of demo once I finish my discussion, and then you can see how easy we can get the report, and then you can see the near misses and all kinds of different things that this technology can provide. The second question is, what challenges did you encounter during installation, calibration, and maintenance? One thing that I would like to share with everyone is it doesn't matter what kind of technology that you're just experiencing at the beginning, they're all involved with challenging. So, and then there's always learning curve involved. And even the small thing to be installed in the with the new technology, it will need a little bit of effort to learn it and then put a little bit of time to understand the technology. This product pretty much has the same, challenges that we had with other product that, we installed, other technology of the video detection industry. One of the most important part was selecting the mounting location. So the LiDAR detection usually come with the two sensors for each intersections. And what is very important is to locate those, sensors the way that they can cover the whole intersection. The one advantage, from the installation of the LiDAR detection to others is just they don't need to be up high. You can just install them between 10 to 12 feet from the ground. And that helped a lot. So you don't need the big bucket trucks to do it. At the same time, like every other, new technology, we need a network. We need the communication. So it could be, wireless. It could be, fiber. So as the city of Norwalk, so all of our intersections are connected, to the TMC with the fiber. So to get the best out of this product, you need to have a good communication infrastructure. And I kind of recommend before we just move up to any other technology to our traffic system, I think we have to a little bit, emphasize and then put some effort for our communication infrastructure. Other, challenges, which, I can't say challenges. Those are the things that involves just integration with the controller. You have to fine tune the detection zone. Steve will really talk about it, in a much better way. And also, what is very important is the staff training. So it's a new technology, as I mentioned. We have a learning curve. So we have to have, some effort and time to make sure to understand the product, how to use it, and how to maintain it. So staff training, it's a very important part. A couple of, lesson that we learned, and this is not just because of the installation of, the LiDAR detection, pretty much again for all the ITS product, is just planning the installation carefully up front. That will save a lot down the road. So you got to make sure that you have everything in place, all the communication, make sure you have a copy, you have, all the equipment you needed. You already, had a site visit before, where you want to install it. So those are the ones that definitely will help on the day of the installation. Also, the good communication, as always, between the vendor, contractor, signal technician, and agency is very essential. And now we're getting to the third questions. The third question, I'm sure that everybody, wants to know about it. So how do you justify the investment compared to video detection or radar? To tell you the truth, it's at the beginning, I thought, and as a matter of fact, I talked to our colleagues and other traffic engineer and the people who are in this industry. We all think the LiDAR had a higher upfront cost. But after the discussion with the people who already have the unit installed in their town or city or state, and also the manufacturer and the vendor, we found that the price is affordable and competitive with all the available detection in the market. And that was a very happiest start for us. So we don't need to worry about the cost to justify, because instead of doing this, we can at least do the demo with another product. But one thing that I would like to suggest to municipalities, state or whoever, is that we shouldn't evaluate any kind of ITS technology based on the purchase price. To me, as a traffic engineer who has over 25 years of experience, I know price is always, playing a big role, but these days, I think we have to be a little bit more open to look at the technology first. We may not using it down the road. We may not be able to afford it, but it would be nice to be open, get the presentation, from the manufacturer or vendor or whoever it is, understand the product. And then once you understand that, it's much better for you to be able, it's a better way to kind of sell it to your common council as a municipality. And you may, have a chance to get the technology that if you think you can save life, if you think you can just ease the traffic, or if you can make the road safer. So to me, be open, get the demo, take a look at the technology. If you don't want to use it, that's fine. You just learn a little bit more about, what's out there. And I'm sure that there are so many other funds available that if you really think that it's needed for your, city or town or municipality, I'm sure you can find a way to purchase that. So, basically that's all I have as far as introducing the LiDAR detection. To just close this conversation, as a transportation professional, we're all working toward the same goal: improving safety, right? Increasing efficiency and making better decision with better data. What I would like to say is LiDAR detection isn't the answer to every challenges. But what I can say, LiDAR provide a valuable tool in the ITS toolbox. I hope, it was helpful, just a, brief conversation about, the LiDAR detector. I would like to just show you a little bit of, information about the demo unit that we installed a few months back. Let me just share my screen. Anybody can see it? All right.
Yes, looks good.
All right. So they call them Blue City. That's how you are going to introduce to the GUI of the LiDAR detection in here. So in the Blue City on the first page, what you see here, you can, see the objects are moving at the intersections. They are, 3D. You can see all 3 dimensions of the objects. And also you can see some information about the counting. So you have, for example, 5 pedestrian, and the interval is 15 minutes. So you have 15 vehicles. And then there are so many different classification that you can, adjust. You can pick to be shown in the software. So here there are some analytics that we talked about it. This is one of the, very important part of this technology, that it will provide so many different things and separately in a better, area. So when you go to the Blue City analytics, so you can see count, you can see speed, conflict, PET rate, which is the post encroachment time, red light runner outside of crosswalks. There's so many different things that we could do. I'm just going to go over a few of them. Let's just do the count. You can see the count for different road user and a different, graph on a time-based day and from each direction. So you can see there's a southbound left turn. You have a southbound right turn, southbound true. And then for the northbound is separate. So each direction separately provide the count. And if you want to get a report, we can just download it, and then and then all those numbers going to be there. So I will show you guys download version as well down the road. Let me just go to the next one. The next one is the speed. So you can see the speed exactly in the same way that they provide the volume. You can get them on a different time, again different approach, and at different time there's a schedule in here, so you can just go back based on our understanding. So we installed this about 3 months ago, but as far as my understanding, I think we can go back for 1 year and then to get the data, maybe more. But this is something that, is not 100%, but that's as much as I know. But one of the things that, so the volume and, speed, it's something that, basically, everybody knows. One of the things that we don't have it in our, basically detection system, it's the conflict. It shows the near misses. That's very important at the intersection. As you can see here, The near misses, it's including pretty much everything. So we have vehicle to vehicle, and then we have the non-vehicle, versus vehicle. That non-vehicle could be pedestrian, could be bike, it could be any kind of road user that, they are just, passing at the intersection. As you can see, we have so many different angle for the near misses in here. Let me just show you a report. I am going to select this part. Yeah, it takes a little bit of time. All right, so there was the heated map, so I selected an area. Let's just pick up the first one. This has happened. This was happened. So 26/7/8 at 9:19. Let's just go. It all recorded, so you can see it. All right, so this is a vehicle that passed by, and then the near misses. Let's see. All right, this is car with car. Let me just go back. I am going to take the vehicle with it. Let's just focus on the pedestrian vehicle. All right, this is southbound. This is car versus pedestrian. Let's see. This is the car, and that's the ped passing by. It goes back. Just look at it right here. You can see the car just come in, and then that's the ped right there. So that was the near miss that they provide. I can show you another one. Let's see. So you can see the speed of the object as well. So let's just go with.
You have about 1 more minute, Fred.
All right. I'm just going to show one more time.
Yeah, perfect. Thank you.
All right.
Fascinating.
So, all right. You can, and this one is perfectly, you can see it. Did you see, that's the near miss right there. It will show it again. Here is the car. It's just passing, and that's the pet. So you can see the near misses, and all of this information will be available. It's available, and then you can, use it. If you have any project, you can definitely use this, videos or, recording to show this is what's happening at the intersection. I am just going to close that, and then I leave it to Steve. Thank you very much, everyone. Appreciate it. I hope it was helpful.
Thank you, Fred. That was great.
Sure. I have to stop sharing.
We'll have Stephen up next.
Good morning, everyone. So as Fred mentioned, we were kind of looking for newer technology in Stamford and in Norwalk. Fred and I had the honor of going to World Congress last year, and we saw a couple different technologies. And I had to beat them to the punch and get the first one installed in Connecticut, but we did it as a team. So we did both install the Ouster system. About 6-8 months later, Ouster kind of reached out to us and said they were developing a new product. So the new product is a full color RGB LiDAR system. So if you look at the system here, it's kind of looks very similar to what Fred just showed you. The key difference is once you enable kind of the full color in it. So right now it looks very similar. Once I go in it and I change it to the RGB, you'll see actually all the colors, everything that is coming in is actually full LiDAR. It's not a camera. All the crosswalks and all the images are being picked up by the LiDAR. That's not any photo or anything. So I can also go in and turn on the vehicle to get kind of color out of the vehicles. And you can actually see you get a lot of high res data and everything from this. You can actually classify vehicles and pedestrians a lot better. If you look around the intersection, you can actually see everything that's being picked up here is being picked up through the LiDAR. So there's no base images. All the sculpture in this top right corner is being populated by the LiDAR itself. This is definitely helping us kind of map the intersection better and get real life data from the intersection. It's also been helping us to concentrate a lot better on pedestrian and cyclists. So we were looking for a technology. We already had a couple technologies that would concentrate on pedestrians, but the cyclists were always a iffy category. So this really gives us the ability to classify large vehicles, pedestrians, get speed data. We can turn on, basically all the information on this. I do have this pause so you could see it. So basically you could see, the speed, the traveling, the heading, how long they're in the frame. It gives them a unique identifier as well as classifies them as whatever predetermined classifications you're trying to get. It really does help us do kind of anything we've thrown at it so far. We are playing around with pedestrian zones, pedestrian extension zones, as you can see in the crosswalks here, in different kind of pedestrian kind of monitoring and everything. I know Fred kind of did touch on the Blue City app. There are other zone analytics as well that you could do that basically give you raw sensor data. And that is basically broken into approaches and phases based on what your zones are set up as. And you can get graphical or, printouts of basically the last hour. This will continue polling of live data. So you can actually go, and as I scroll down here, it gives me all kind of the information. And then I can always, open that up and see it more. There is a lot of kind of diagnostics and alerts built in. So you can predetermine alerts, have everything built into you. There's over there updates, there's remote configuration. There is so much packed into this that we're kind of still learning ourselves. So it's an ongoing process of, trying to adapt new technology. As Fred mentioned before, this is kind of a low res option of showing you a live intersection. So you can see pedestrians are actively walking into the zones. You can see all the vehicles and basically all the queuing and everything. Another thing we really liked about this is if you go into the setup page and go into the zones or here you get live representation of our phase statuses, our detector statuses, and actually our load switches. So basically, it's a lot easier for us to help troubleshoot into the field and remotely and help a technician in the field or, try to diagnose a problem remotely. There's so much information that's embedded into the software, and we're still playing around with seeing how far this long range can see back and playing with newer zones. And as you can see, we're putting advanced detection zones further back just to see everything. It's definitely, you can see all the kind of LiDAR points coming back in. It's definitely gives us a lot more information than we're used to. I haven't found anything it could not do yet. So that every time I throw something at the LiDAR system, it's like, yeah, I could do that. Yeah, we can figure out how to do that. So it really is growing with us. We're actually, I think, have the issue of us trying to adapt to what it could do, because so far there's nothing that I found that it couldn't do for the city. That's it for my end.
Thank you, Stephen. All right, and we will turn it over to our DOT Signal Lab reps.
Rob, I think you should probably go first, man.
Sure, yeah.
Thank you.
All right. So, up on my screen, I have what is not Ouster. It's still LiDAR. This is another group that we've been testing called Seond, See Beyond. So we've been testing both Ouster and Seond at the DOT. We have, I think, 5 Ouster sites at the moment and 1 site for Seond. And since Fred and Steven were so good to show you guys all about Ouster, we'll show you a little bit about Seond. So first of all, what I'm showing you is not our entire intersection. This is only half of it. What I'm showing you right now is one of our sensors, and why I'm only showing one of them is to kind of contrast it with one of Ouster's sensors. Ouster has a 360 sensor. Meanwhile, our sensor right here is a 120-degree view. It's picking up two approaches, and it's actually getting out real far for one of our approaches. One of our approaches, we have some detection out some 300 feet, and this is Seon's long range sensor. So it's getting both stop bar and advanced detection all in one go. So instead of having a bell camera and radar system, or a bell camera and advanced video detection, you just have one sensor to cover stop bar and advanced, well, excuse me, 2 sensors to cover the entire intersection. So clicking over to our fusion of 2 sensors, now we have, similar to what you guys saw before, the full 3D view when it eventually comes in. So we have our full 3D view of the intersection. You see cars coming in and out. You see all of our zones. We've been told at the lab that we are pretty ambitious with our zones. Right now we have, I think, 77. We created zones for this, that, and everything. With our view here, it differs a little bit from Ouster. I'm only going to give a couple more bits of contrast between Ouster and Seon before I focus exclusively on Seon. So some things you might notice are the, well, first of all, the lack of color with Seon. Ouster has this new sensor that has yet to even be released. So yeah, Steven is really the first one. So they have their color sensor to give you a more in-depth view of it. Seon still has the LiDAR sensor, which I'll talk a little bit more on why they don't really need to have color, as awesome as it is. And I'm not trying to belittle how incredible it is to have color with LiDAR. With Seon as well, you don't have the Google Map underlay. You might not have noticed on the previous LiDAR views because you have all the point cloud over it. Underneath there was a Google Map underlay, so that way you can try to align your sensors. With Seon, you don't have that Google Map underlay, you don't have that color, because uh, using those 2 things to align the sensors are really unnecessary, with Seon at least. With Seon, when you first boot it up, you can do a fusion of these 2 sensors. So instead of just having them at 2 random points in space, the system will automatically fuse them together, and it even auto-populates some dummy zones that it notices cars are going in and out of this area in particular more often than not. So they'll put some dummy zones in. And most of the time, those zones aren't the way our plans are spec'd out, so you have to adjust them. But it is a really neat thing to do where you can just load it up, hook your sensors up, and when you go in, it just automatically configures everything. There's a lot of fine tuning on our end, so it's not you just plug it and walk away, but it is very interesting to see that, to have that. Now, to talk more about Seon and not contrast it to Ouster anymore, right now you have your live view of traffic. You see our uh, zones being lit up when cars come into them. We have all of our yellow zones are our detection zones, so all of that is sending a call into the controller. We even have zones way out in the back. I think, yes, our furthest advanced detection zone is at 300 feet, so it's wonderful that I can be doing stop bar and advanced detection all in one go. We have the red and pink zones are for our pedestrian counts. We're playing around with that a little bit more, and possibly down the line looking at implementing pedestrian calls right from the LiDAR instead of having a push button, or rather in addition to having a push button. With these, the smaller zones that are in front of our stop bar, we're using those for our counting zones. So we'll have, actually I can pull that up right here, for our turning movement count over the day. and we can see everything. You can see that somebody took a right turn from a straight through lane, which, not normally allowed. But we have tons of counts with that. We have these purple zones that are being used. We're starting to play around with red light running and getting recordings for that. Similar to what Fred showed, you can also, from this red light running, you can get a short clip in a 3D space. So you can, when somebody runs a red light, you can actually view it and you can see how far it was after the red light, after it changed to a red light that they ran it. And you have some pretty interesting clips of people just blowing a red light at 2 in the morning, or there are some false calls where somebody went, well, maybe not a false call, but calls of somebody that go through right after it turned red. We also have our actuation screen, which is very similar to the last one, except it gives a more in-depth view of when calls are actually being placed. You can see when it lights up in outlined in green, there's actually call being put into the controller. Meanwhile, these whites are just showing that a car is going through that zone, because a car going through a crosswalk wouldn't be putting in any calls. Also, well, I didn't want to compare and contrast so much, but again, similar to Aster, you have your phases. You can view your phases, what's currently active when it turns yellow and red. So that's a neat thing to have in your back pocket. You can also see all the different detectors as they light up and as they're coming in. Then from our dashboard, dashboard again is seeing all the data that you can see in the live view, except in a more user-friendly view. You can see the volume over the day. It looks like it's dropping off, but that's only because we're not actually at 12 noon yet. So I guarantee that in an hour, it'll be just as high. You can see our turning movement counts throughout the day for each approach. Like, this is just our northbound approach. Click over to eastbound, southbound, and westbound. So you have all of those turning movement counts coming in. And then, of course, you have an overview of the system, just like really any detection system, not just LiDAR. You have your performance, you have your uptime, health, things along that nature. We are also, we haven't established this yet, but we're playing around with setting up an API where if one of these sensors comes down, we'll actually get a notification. That way we won't have to, oh gosh, that way we won't have to just hope and pray that everything is up and just check every now and then. So we'll know ahead of time when it actually goes down. I think that's actually just about all of our, all of the major bits of our Xeon system. And it's been chugging along for, I think, a couple weeks now is the last time we really went out there to adjust. And it's great with all of the LiDAR in general. You just plug it, and once you get everything all set up, you just let it go. It's awesome to show people because everyone loves to see the 3D space made up of lasers, but it's really low maintenance once everything is chugging. I think that's about it from my little demo of Xeon, and I'll toss it over to Andrew for a short presentation.
Thanks so much, Robert. And just a reminder to everyone, feel free to post any questions or comments that you have in the chat.
So I have just a small presentation that I would like to share, and it's part of actually a presentation that Rob and I have been working on now for a few months, and as a kind of like a holistic like overview of the technology. And like Rob was saying, we're part of the CTDOT and the Signal Lab specifically. We have an opportunity to work with both of these technologies or both of these companies that are providing a similar but different approach to using LiDAR in ITS applications. And so I'm just going to go over a little bit of some of the data that you can capture. I know we've kind of touched on it over the course of this presentation. Um, Fred was going crazy with his showing off his data. So I'm gonna just try to reinforce that what you can get with this information is is accurate and and more importantly, I want to enforce that LiDAR is it's a 3D space. And why that's important is when you're dealing with things, like your near misses and red light running or like pedestrian events and things like that. When you're working with cameras, the cameras are interpreting images, 2D images, and there's all sorts of calculation going on in measuring distances and things like that in the camera and in the processors. And it's not to say that they're inaccurate or anything, but with LiDAR, you're you're getting a 3D object. You're getting two 3D objects interacting in the world, whether it be two cars, a bike and a car, a person in a car, all those things, and you're getting a true spatial relationship that can be used to improve safety, or like if you're seeing high volumes of people and you're seeing high numbers of near misses or cars that are running red lights, and maybe there's somebody walking across an intersection or something like that. You can get a very accurate representation of like how that vulnerable road user is interacting with the intersection. And I think that's what is going to be really important going forward with LiDAR technology in general. And both Ouster and Seond provide, very similar suites of data and data collection. And, Rob and I, we talk to both companies every other week. Sometimes, we'll touch base with them if we have a, specific issue or a question that we're asking. And they, both companies have been very open and very, willing to work with us, and we try to, provide feedback and things like that. And it's been a very fruitful experience working with both companies so far. And to that point as well, they want to hear from customers and things and new users, and improve the technology for our benefit, for DOTs and municipalities. So one major aspect of the LiDAR that has been improving over time is the vehicle classifications. So this slide is the Seond, data collection, and they can categorize up to 8 categories at the moment. The goal for both is to get to the 13, which I have a slide on later. And it's important to have these classifications because you want to know who's on your roads and who's using them and who's affecting the operations of your signals or your corridors. I mean, just as an example, and on the Berlin Turnpike, there's any number of different vehicles that you can run into that maybe you're not seeing on a, more, slowly trodden road, out in the middle of, northwestern Connecticut. So this is all in the name of collecting information so that we can improve the operation of our signals and the improved safety at the intersections and providing accurate information such as the vehicle counts that are updating in Seond. Those are updating I want to say every minute. And so you're able to see that kind of expansion and that road use over time. And it's it's been very interesting to see kind of how these numbers pile up by the end of the day, both at our Sion location and our representative ouster locations, which to what Rob said, we have 5 of those, and we have kind of peppered them all over the state in different spots to kind of test different aspects of the systems. And so far, they've been very successful. The um, the ouster locations, we had an installation go up in December, and that was in Newington, and has been running alongside a grid smart that we have there. So we've been able to at least compare and contrast in different conditions, night, day, storms. I mean, we got hit with those winter storms this past winter, and the lidars, the lidar just it's not affected in the same way as a camera. You're not cleaning off or you're dealing with like dirt and grime that's flying up from vehicles and things like that in the middle of the day. Um, and the lidar was holding true the whole time. We didn't get a complaint about missing detection or anything like that you would normally get in situations of poor weather conditions. So, but this is all in the name of collecting data on you know speed and heading and you know size of your vehicles, the turning movement counts like Fred had shown earlier. This is just kind of more of what Fred was talking about. Um, and Ouster currently has the 5 categories that they're piling things into, but they also have the ability to add custom vehicle detection or vehicle classification categories um, that can get pretty you can get pretty in depth with it. Um, and those are all things that Rob and I have been investigating over our months here with the technology. So, and to that point, the this is from the federal DOT and how they classify all the 13 vehicles, and this is just kind of like an ongoing development with the LiDAR systems. Obviously, the goal would be to get all 13 and be able to do that accurately. And it's every day like we're striving towards more and more information, more and more accuracy. So the LiDAR provides that. Uh, Especially with the new sensors that are coming out and how it's the use of AI to help develop products and the back end
Yeah.
software. So, um, so just as like a summary, I wanted to just point out a couple things with the LiDAR. So, with a camera system, you're setting up the camera. You can put it up on a pole, and with the 360 lens, like you're able to capture a certain uh, radius diameter of an image. Both of these companies use a minimum of 2 sensors, and the setup for it is typically on adjacent poles, steel, span poles. They're located between 13 and 18 feet, and they're both are fairly lightweight, but having them on the span poles means that it's not whipping in the wind the same way that a camera will. And so you're always getting a very rigid, very sturdy, quote unquote image from the sensors. Um, I found that working with our maintenance crews that they appreciate the lower height to install. Um, and just like with any product, there's a learning curve to, very efficiently putting these up. And I think, it'll only take a couple to really get the guys, whoever's maintaining your equipment, to get them to do a couple of them, and then they'll hit the ground running with it. But the whole thing with these is that they do have to be set up very specifically. And each company provides tools, or each of the companies we've discussed today, they provide tools to do mock-ups and things that allow you to look at how an intersection will be covered, coverage wise, in a pretty accurate way. So you can go in confident knowing that your setup is good or not. Um, so it's it's been quite an experience working with both companies, and the the differences between them, and what they each can provide. Um, like you can set it up and suit it to however you need it to, which is good. So that, I believe, is all I have.
Great. Well, thank you so much, Fred, Stephen, Robert, and Andrew, for sharing. Just a reminder, this session is being recorded and will be posted on our YouTube channel. So we did have a couple of questions in the chat, but in the interest of time, I'm going to ask the ones that have not been answered just yet. So there's one here. Could Fred or anyone elaborate on the communications requirements for installation at a signal? If it's in a system with a copper wiring, would that work, or should it be fiber? Are there issues with cell modems, wireless radios?
Steve can answer as well, but so this system, if you want to get the best out of it, if you want to communicate with the unit from your TMC, fiber is the solution. I mean, wireless modem, can do the job, but sometimes the reliability is not there. So my recommendation is the fiber optic. But as far as the copper, the question that it's there, I am not sure if the copper could handle the bandwidth, especially if you want to go with the color version of the LiDAR detection. And then that does not affect the detection area. It just affects the communication from the TMC to the camera. So you could do all this stuff that you can do, from your office, and you don't need to go to the site. The communication is just for that, to communicate with the product. But, as far as the radar detection at the location, they're not related. But if you want to communicate with them, I think fiber is the best solution. Steve, if you have something to say, please. Yeah. I was just trying to answer the question, and you already answered that.
Yeah, it all depends on what kind of you're looking for. There's no, right or wrong answer there. I mean, depending on what your copper can push. If you can push, 100 meg over copper, then you could be fine to get data, get some live video. But if your copper is kind of on dial up, probably not. Radio, we have great success with radio. I'm using radio for live video, so that shouldn't be a problem. And cell modems too have come a long way. So it all depends what you're trying to do and what your kind of applications are and what environment you're in.
Thank you so much. Dimitri, I saw that you had a hand raised. It looks like you put it down, but feel free to unmute if you have a question. And anyone else, just for the last couple of minutes, if you have a burning question, again, feel free to unmute and ask it now. So I put an evaluation link in the chat, and I will share my screen as well with the QR code to be able to access the session evaluation. Again, thank you to our presenters. You all did an amazing job, and this is really fascinating technology that's up and coming in the industry. So thank you so much for sharing, and developing your presentations to be able to share your expertise with us. We hope this was a valuable use of your time. And again, the evaluation link is in the chat, and you can also access it using the QR code that's shared on your screen right now. We'd like to know what you thought about today's session, if there's anything else that you'd be interested in learning about in this 1-hour coffee and conversation virtual format, whether it's transportation or traffic signal related topics. And that's all we have for you. We'll be sticking on for another couple of minutes if you have any last minute questions. But that's all we have for you, and I hope you enjoy it the rest of your day.